Hey guys, welcome back. I just wanted to talk to you about the material from chapter 12, which is the next chapter. We're skipping chapter 11. So in chapter 12, we're going to talk about volume and surface area of three-dimensional shapes. So today we'll talk about volume, and then we'll do some practice problems from the workbook. This is actually page 179, I believe, from the workbook. So if you want to look there and then just kind of jot any notes down that we talk about. But this is the formula sheet that you should refer back to as you're doing problems on volume. So I'm going to break it down into three sections. The first is volume formulas for prisms or cylinders, and basically what this category is any shape where there are two identical bases. So for example, if you think about a box, right, that would be called a prism, right? Where there are two bases, there might be more than two bases, but there are at least two bases that are identical to each other, that are parallel to each other. Sorry, my very annoying cat is coming back in. That would be one example. Let's say you had, again, you've probably all seen a Toblerone box, right? That would be like this, where there are two identical bases that are parallel to each other. This would be called a triangular prism versus here, which would be probably a rectangular prism. And then there's also things like a cylinder. Right, this isn't called a prism, but it falls in that same family because it has two identical bases that are parallel to each other. Right, and when we have that, they all essentially have the same structure for their formula for finding the volume. And what you do is you would find the area of the base. So imagine if you're making this out of stacking cardboard things, cardboard cutouts, and you had a cardboard cutout that was the shape of this base. And then you made another one that was identical and stacked it on top of it, and then another one and stacked it on top of it until you kept getting all the way up to the top. So you're stacking these rectangular or square pieces all the way up. So the first thing you would do is you would find the area of that base, right? Because again, it follows the whole way up. And then you would just multiply it by the height, whatever that is. So you're finding the area of this base and then multiplying it by the height. And that base changes depending on what the shape is. For example, here it would be a triangle, here it would be a circle. You can even have something like, I'm going to do a horrible job drawing this, but let's say you drew a hexagon and had, oh goodness, and had something like that, where you had a hexagonal base and then just stacked it all the way up, and the bases are identical and they're parallel to each other. So each time you find the area of the base, whatever that is, and then you multiply it by the height. So let's take a look at three very specific ones here. A rectangular prism, that would be the example here. The area of that base right here that we're talking about is length times width, all right, because it's just, you know, again, I drew that kind of square looking, but length times width, and then the height, right? And then if we had a triangular prism, we would find the area of the base. The area of a triangular base is half base times height. Now just be careful here because this base is talking about the base of the triangle. Usually we refer to the area of the entire base as a capital B, just to make sure that you're not getting the two confused. And then times the height of the prism. All right, a cube, which I have not drawn, but that would look like this. All right, that would be the area of the base, which is side squared times the height. But since the height is the same as each of the sides there, you could just say it's side cubed. Side times side gives you the area of the base times side gives you the height. All right, then let's move on to the cylinder here. This is slightly different because this is not a polygon as the base versus these others that I drew are polygons. The volume of the cylinder still follows the formula. Volume is the area of the base times the height, or B is the area of the base of this, the base that's the base of the cylinder, which is a circle, and H is the height of the cylinder. And since the base is a circle, this is the area of the base, pi r squared, times the height. All right, So again, they all kind of follow that same pattern. To find the volume, you find the area of the base and then multiply by the height. And again, I can't emphasize enough, prisms come from two identical parallel bases, all right? So, and we're going to look at some examples of that in just a second. The second family, right in here, would be prisms or things like it. And these all come up to a point, all right? So if we have a rectangular pyramid, think about pyramids of Giza, where we've got a rectangle or a square as the base. Actually, there's two separate categories for that. If we have a triangular prism, that would be a triangular base, and they all meet at one point at the top. All right, so the difference between a prism, which we just looked up here, and a pyramid, which we're looking at here, is in prism we have two identical parallel bases, and in pyramids we just have a single base, and then from the vertices of that base, they all meet up at the top. All right, so the difference between the formula, if you notice here, this is saying volume equals 1/3 base times height versus up here where it said volume is base times height. Again, this is capital B, which means the area of the base. So the difference here is this 1/3. Everything else is identical. And imagine if you took, it's easy to imagine it with a cylinder, I'm sorry, a cone. If you took a cone and then you kind of made a cylinder around it, right, that kind of just fit exactly in there. It does kind of look like you're shaving off about 2/3 of this and leaving 1/3 of this cylinder to get the cone. So that's kind of just a general way to think about where that 1/3 comes from. When you shave off the sides there, 2/3 of it is shaved away and 1/3 of it is left. So we've got 1/3 the area of the base times height, again, where B is the area of the base of the pyramid and H is the height of the pyramid. I'm so sorry if I accidentally say pyramid when I mean prism, or prism when I mean say prism when I mean pyramid, because they both start with a P. So again, hopefully if I make that mistake, you'll be able to figure out what I mean. All right, so again, let's look at a rectangular pyramid, a rectangular base. We're not making an identical rectangle above it and drawing up the four sides here. We're taking, and each of these corners right here are meeting at a single spot up in the top. Right? And so we find the area of the base, which we do by doing length times width, and then we find the height. Usually that's, from that point right there, we're going to drop a perp right down to the center of the base. And then, so we multiply the area of the base times the height, and then take 1/3 of it. All right, same thing if we had a square pyramid. So the base is a square. So we're just going to call each of these S for side, because there's no difference between any of them. And then we're going to draw up here to a point that's centrally located right above there. So we find the area of the base, which is S times S, or S squared. And then we find the height of the pyramid, which is essentially dropping a perp from that vertex right there. That's the height of the pyramid. And then we take 1/3 of it. Same thing if we had a triangular pyramid. These are a little bit harder for me to draw. And that triangle does not need to be isosceles. It could really be any shape. But we've got that vertex up there, and we're drawing to each of these vertices right down here. So we would find the area of the base, and then we would drop a perp here to find the height, and then we would multiply it by 1/3. So 1/2 base times height. And again, notice that this is a different height. This is the height of the triangle down here, and this is the height of the prism, right? So we distinguish them. This H is lowercase to mean the height of the base, and then this H is capital to mean the height of the pyramid. And then don't forget about that 1/3 out front. That's an easy mistake to make. All right, and the final one that's in this category is a cone. And again, the reason that we're distinguishing the cone from the other types, same thing, the reason we distinguish the cylinder from the other types is because that base is not a polygon anymore, but it still follows the same pattern. So here we would find the area of the base, which is pi r squared, and then we would multiply it by the height of the cone, which we're calling capital H because it's the height of the cone, and then we're taking 1/3 of it. Right, and then the final section is the volume of a sphere. So we've got something like this. The only piece of information that we have about a sphere is its radius, right? Because that's how it's formed. It's just we send out that distance in every single direction. So to find the volume of a sphere, it is just 4/3 times pi times r cubed, right? So notice that we're in 3 dimensions. The exponent now is a cubed. When we did cylinder, it was 2 pi r. The exponent was a 1 because that was just a length. In area, we had pi r squared. That's a 2 because this is a 2-dimensional shape. And in the volume, it's 4/3 pi r cubed because now we're talking about 3 dimensions. Okay, I'm going to stop this here and then we will switch to page 180, 181, and 182 and start talking about actually finding the volumes.